Hi everybody, I'm Ali Tawakoli and this is part 3 of our UML tutorial series. In this part, we want to talk about activity diagrams. So if you're ready, let's get started. Alright, activity diagram. So activity diagram simply shows what actions occur to achieve an ultimate goal. It actually shows us what actions in different situations should and or must happen step by step so that a functionality can achieve its ultimate goal. Like use case diagram, activity diagram is also drawn from a very high level. I mean, it doesn't get to in so much technical details, so it's useful for anyone who likes to understand how a functionality can achieve its goal, like business stakeholders, product owner, designers, developers. It doesn't matter. Use case description and its steps of execution, main flow, and its extensions help us in drawing an activity diagram. Because as you know, the main flow of a use case uh, actually shows us what should happen step by step so that that use case, or let me say functionality, can achieve its goal. So those steps obviously can help us very much in drawing the activity diagram and its actions. So here is an example of an activity diagram which is going to show us how a walking process can be. We all know how to walk, so I thought that it can be a good and simple example to show that if we were supposed to draw an activity diagram for our walking process, how it would look like. So in our example, we will understand what are decision and merge notations, what are fork and join notations, time event, call activity node, and expansion region, flow final node, object node, interrupting event, interruption region. What are these? Swim lane, object output and object input, signals, send or receive, and some other terms. I will go back up there, but let's take a look at these topics and see for whom an activity diagram is. It's good for business stakeholders, system designers, and developers. What is its purpose? Modeling business requirements and the project workflow by using activities, describe the parallel branches and concurrent flow of the system. Right? Important elements. What are the important elements? All right. Action. Action notation actually means action. Action means actions that system itself needs to take as it continues operating. An action or an activity that should or must happen so that a functionality can achieve its goal. All right, that's it. Okay, object node shows data that is involved through the activity flow. If we are going to represent data that is taking part in our activity flow, we will show it by the object node notation. Object input and output pin. It's a pin that attaches to an activity to show an activity's output or input data. It's actually like object node, but the object node simply defines that such data is included in the activity process, but pin emphasizes that such data is required and needs to move from one activity to another. All right. decision and merge notations. They both look like the same. They have a diamond shape, and the decision is actually like the if statement in a programming language. If a statement A is true, then do this, and if statement B is true, then do that. A decision can have one input but multiple outputs, which means that after the decision has been made, system will continue only one of the drawn outputs, just like the if statement in a programming language. Only one statement can be true at a time. And merge is also in the same diamond shape, all right, but receives the outputs from the decision and has only one output to continue and hand it to the desired activity. So when a decision has been made, only one of the uh, activity flows will continue, and after that it is done with its actions and activities, then it may be comes to a merge notation, and that merge notation as notation's output will continue our activity flow and goes to another action, etc. We will take a look at it in our activity diagram example later, so no worries. Let's go and see what are fork and join notations. Fork and join, like decision and merge, both look like the same. They are some thick lines, horizontal or vertical. We will take a look at them in our activity diagram example later, so no worries. So what are they? They are actually when multiple activities are going to happen at the same time, such as threads, we show it by fork. And unlike decision, all outgoing paths are going to be followed. So as we have explained, in decision, only one path is going to be followed, but here for fork, all the outgoing paths must be followed. Join is also in the same shape of fork, but like merge, receives inputs and has only one output. All right? Interruption region demonstrates an activity that can end before the completion of the whole activity diagram. Actually, an interruption region includes an interrupting action like user cancels creating an account or cancels logging in, etc. This is an interrupting action and leads to, for example, another action which is account canceled. So that's all there is to an interruption region. Flow final node. It's a circle with an X inside of it. It shows that a flow ends without ending the whole process. It actually happens in the forks most of the time when different activities are going to happen at the same time. When some of these activities don't come and join together in a join notation, and their own path is going to end for itself, and by ending those paths, our main activity flow is not going to end, then we will show the end of those paths by the flow final node. Send receive signal, an activity which is going to have some interaction with an external outside source. Send signal sends info to an outside service to do a particular functionality, and receive signal will receive some info from an outside source. Receive signal comes after the send signal in most of the times. Actually, signals are going to show that we are actually working with a third party or an outside source or service in our activity flow. All right, what is the expansion region? Represents some groups of items that need some sort of actions to be performed and on all of them. So in our expansion region, we are actually going to do some actions on different items, multiple items at the same time. So uh, actually, those actions are going to happen for all of those items. So we put those actions in an expansion region. What is partition? It is called swim lane 2. Different activities may involve different participants. So partition will be used to show which participant is responsible for which action. It actually helps us to organize our activity diagram a little bit. For example, ordering processing activity requires shipping department and accounts department participants. So with partition, we separate these two participants and draw the related actions in them so that we will know and understand that such actions are related to the shipping department and those actions will be related to the accounts department. It can help us to organize our activity diagram, and it's a good thing. All right. So that's all about the important notations. Let's take a look at and see what points we need to consider when we are drawing an activity diagram. What initial nodes can be an activity diagram? Well, most of the times the start initial node is going to start an activity diagram, and sometimes the time event or receive signal can be the initial node that actually is going to start our activity diagram. If a time event is an initial node in our diagram, then it means that we like to demonstrate a repeating activity. I mean, an activity which repeats after this specified time again and again. I will show it later in our activity diagram example. No worries. In decision element, we should make sure that only one got evaluated to true because one of the outputs should continue. This is just what I have explained earlier when I was talking about decision notation. Only one decision must continue the path. All right. So what are the steps to draw an activity diagram? Step one is to start from the initial state, and then we can convert all the use case descriptions, execution steps in a visual picture. And finally, activities come to one final state to end the system process. I mean, we will start the activity from an initial node and then different actions in different situations based on different decisions or forks will happen, and then we will come to a conclusion and an final state notation. And that's it. That's how we will draw an activity diagram. All right, let's go all the way up and see our examples and see how we can draw an activity diagram practically. All right, in our example here, we are going to demonstrate how a walking process can look like. As I have explained earlier, most of the activity diagrams will get started by the initial state notation, which is this black dot over here. Then by the incoming edge, we will go to our first action, which this notation is here, and our first action here is this: ask brain to walk. And by an outgoing edge, we will be led to the second action in our process, which is think about the ability of walking at the moment. Then we will come to a decision. If it's possible, then do this. If it's not, then do these actions. So we will have a guard conditions over here. These are the guard conditions, and in most of the time and in real examples, we will use OCL to write these guard conditions. But we can also use natural language like what I did here in this example, possible or not possible. So if we can and we have the ability to walk at the moment, if it's possible, then do these actions. Let me explain first if it's possible. First, analyze the environment and then come to the walk action, which this action is not actually a simple action like these actions that we had already. This is actually a call activity node. Why? Because this icon over here actually shows us that it's a call activity node. Call activity node is actually another activity diagram for itself that includes some other actions. So after that, analyze the environment action happens, we will come to the walk. So in walk, what is going to happen? These actions are going to happen. We will again start it with an initial state notation. Then by fork, we will show that these two actions are going to happen at the same time. Take a step and prepare for the next step at the same time. Then both of these actions will join together and we will end the walk process by showing the final state notation. So that's it. And we will after walking we will come to a merge. All right, so that was all about if the ability of walking at the moment is possible. If it's not possible, then to do these. What we're going to do, we're going to actually wait for 30 seconds. This is time event action. We will show the time event action like this. After 30 seconds, then do this process. Ask brain to walk. This stereotype here actually shows us that this action is not a simple action, but it's a process. Ask brain to walk is actually going to represent, in my example, is going to represent that let's come and start everything from the beginning. Ask brain to walk, and then again think about the ability of walking at the moment. I mean, after 30 seconds, we will come over here and start the activity flow from the very beginning. And all of these come to an inclusion with, we will show it by the merge notation, and then everything ends and our walking process actually ends. We will show it by the final state notation. That's our first activity diagram example. In our second example, we have used the expansion region as we have explained. The expansion region actually represents that anything in the expansion region is going to happen for multiple items in our system. So for example, when we are going to overview some bugs, and after that this action happens, overview of bug report, we will come to an expansion region, and for each bug we will do the following: discuss bug report, we will come to a decision. If it's a real bug, then we will go to here. If it's not and is an operator error, then we will come to an flow final node. As we have explained, the flow final node is going to only end the path of the decision or an fork, and is not going to end our whole activity process. So because if it's an operator error, we are not going to do anything else. We will just end the path of the process of this path by showing the flow final node. And if it's a real bug, then we will continue and get out of the expansion region and notify engineering of bugs to fix. In another example, I have shown that our initial node can also be a time event and not the state, the initial state notation. It can also be a time event. So actually, as we have also explained, if our initial state is a time event, it means that every 30 seconds, all of these actions are going to happen. So after 30 seconds, we will come to an interruption region, because here we will have an interrupting event. We will show an interrupting event by this arrow like this. So here we will have an data that we are going to use in our system. We will show data with object node. What is the data? It's account info, that is that its state is currently pending. Then we will verify account, and if account has been verified, simply we will get out of the interruption region and change our data and say that it has been approved, and then we will end the process. Or this can happen: user cancels and account canceled, and then we will again end the process. And this is an interrupting event. In another example, we have demonstrated the swim lane, as we have discussed, to demonstrate different participants and the actions related to those participants. We will start the activity flow and check if message is not spam. We are actually going, this is an activity diagram for visualizing spam checking. So in our spam checking department swim lane, we will have these actions. Check if message is not a spam, and by an object output pin, we are actually demonstrating that such data, the message, is included in our action flow, in our activity flow. So the message is going to move from this action to this action, which this action is actually a send signal, because we are using a third-party library, for example, in our system. And the third-party example is send message for spam checking. The spam checking is a third-party library, so we have shown it with the send signal, and its result will go to the receive signal, which we have created for our system to receive the results from the third-party library. So after that the results come to our system, we will then receive them by the receive response action, and then we will go to a decision. If it's a spam, mark message as undelivered and end the process. If it's not a spam, then do the send message process. And this is not a simple action, because we have defined it by the process stereotype. And object output pin and object input pin can have names, like in our example here. Here I have shown that actually this action is going to send the object as a message to the third-party library. And the third-party library, for example, property that receives this object or data, its property name can be the content. And what is this? The transformation. What is this note about? This note actually defines the rule that how these two actions and how this object is going to move to this action. It actually shows us exactly that the message object, the whole message object is not going to the send message for spamming checking action, but its content only is going to be moved to the next action, which is send message for spam checking. So I hope I could explain this clearly. And that's it, all about the swim lane and object output pin and object input pin and signals. And in these two examples, I have also explained that, like what I said earlier, again, the initial node can be the time event or a receive signal. So in a real system, sometimes in a real-world system, a third-party library that we are using or something like that will give our system a data which causes our system to start an activity flow. And in that case, we can demonstrate that by using the receive signal as an initial node. So in our example here, when a user reads a message, as soon as he or she reads the message, then and the reading message activity will be fired, and in that activity flow we will mark message and read and end the process. And that's it. That's all there is to an activity diagram. We have almost reviewed everything important about it. So in our next part, we will discuss about the class diagram. So see you soon, and don't forget to subscribe to be notified about our next tutorials. So see you soon.